Okay, so last time I think we got through question 4. Does this look familiar to you?
Yeah.
There's on February 12th, we got through 4. Okay, so let's just keep going. Have a look at number 5.
I'm so bad at these. Okay.
Well, I'm glad you're good because I can help you tremendously. The only thing you have to do is remove the parentheses.
Okay.
Gather all like terms.
Okay, so x squared 3y squared plus.
First of all, can you remove the first set of parentheses without affecting anything?
Yeah.
Always. Unless there's a negative sign in front of it. Negative sign in front of it, you wouldn't be able to remove it. But usually the first set of parentheses, you can always just disregard. So I'm not going to change anything there. Now how about the second set of parentheses?
It has that minus in front of it.
Which means it's going to affect every term that's in that second set of parentheses.
Right.
Basically, you change every term and change this to a plus sign.
Mm-hmm.
Okay, so let's. What I'd like to have you do, Abigail, is it Abby or Abigail?
Abigail, yeah.
Okay. What I'd like to have you do is focus on our common theme here and work the problem out loud. I want to see how you're thinking, what your thought process stuff. Rather than do it on a piece of paper in front of you and you the answer.
Okay.
Okay. So let's just take this term by term. What comes next?
So plus x squared y.
Keep going.
Minus 3xy squared.
Okay.
Plus 3y squared.
Okay. Now gather all like terms. And just start with that one right there. Are there any others like that?
Yeah, I guess the fourth term or just the first one and the second.
Okay. So add those together. How many do we have?
2.
Okay. Circle the ones we have. We have that one. This squared. Oh, that's it. That's all of those we have.
Mm-hmm.
So what do we have? Well, we have one of them and another one.
So 2x squared. And then would it just be? Oh, okay.
Think of this as an apple. An apple is x squared y. Well, this is another apple. When you add one apple to another apple, you get 2 apples. Okay. Now let's look at this. And I included the sign with it. How many of those do
you? 2.
What do they add together to be?
0.
Okay. So we've eliminated that term, that term, and that term. Looks like the only thing we have left are these two. What do they combine?
2x squared y.
Okay, I do need the plus sign because it's part of a polynomial.
Mm-hmm.
And it's 2x y squared.
Oh, yeah.
That's that answer. This is one of those questions where you don't really need multiple choice. The only value of multiple choice is it verifies that your answer is on, and that, you know, confirmation.
Okay. Yeah.
I want to try one thing, if you don't mind, just a second.
Okay.
I would like you to log off and log back on. I won't.
Okay.
Meeting ID number. Do you have it still available?
Yeah. Yeah.
Just go ahead and log off by clicking on the X, and then log on. I presume you found an icon on your desktop that was the GoToMeeting icon.
Yeah.
Okay, cool. You didn't have to go to the website or download it or anything.
I did at first, and then I realized I had to.
Okay. Let's try having you do that. It should only take about 30 seconds, and I think it might eliminate that echo problem.
Okay.
Did you log off yet? Interesting. Hello? Okay, let's see if that's better. Can you hear me?
Yeah.
Okay. Yeah. I don't think I hear any echo. Yeah, I do. Still there. That's all right. I'll deal with it. Okay, let's go to number 6. Just to make sure we order. All right. Go ahead and read through that.
Okay.
Okay, so what's the answer?
Okay. Let me. Okay, I got A.
Yeah. Notice that this is in the form y equal mx plus b.
Mm-hmm.
M is the slope. And what slope means is rate of change. So if we recognize that, immediately we can see that that is the slope. That's what his rate of change each year is going to be. All right, let's go to one of my favorite problems. This one, number 7.
I remember we did like work through this one.
Okay, good. We'll skip it. I thought I might have done it. Yeah, because it was one of my favorites. I wanted to do it last time. I don't need to do it again. Okay. Number.
I don't even know where to start with this one.
Okay. Couple things we. We got A. Hold on. Sure. No, not going to work on me. Hold on. Okay. If A over B equals 2, let's try solving for A. What's A equal to? Here's what we start with. A over B equals 2. How do we get rid of the denominator? When you're trying to solve an algebraic equation, get rid of denominator.
Multiply the 2 by B.
Okay. Tell me the next line.
Could you?
What?
Could you do cross multiplication with this, or does that just like?
You don't really need to do cross multiplication. Cross multiplication is just 2 steps in one. Here we only need to do 1 step. You had it. You got to multiply both sides by B. In other words, the way you get rid of denominators is to multiply.
Okay. Yeah, so A equals 2B.
So A equals 2B. Now, let's do that expression. And what do you got? You got 4B over A, but A is 2B. So what's the answer?
2.
Yeah. Now, there is a quicker way to do this, probably. If A over B equals 2, then what is B over A?
1/2.
And this is 4 times B over A.
Got it.
I'd multiply that by 4 and I'd get 2 again. This is a trick you should know. In other words, if you have a fraction equals a fraction, you can flip both of them, and that is still an equation. And sometimes that'll help on problems like this. This is actually a perfect example. All right, let's go. Hold on. This is very sensitive. I got it. Okay. Systems of equations. Remember studying these?
Yeah.
What 2 methods can you use?
Substitution, elimination.
Okay. What should we use on this one? I like to think that when it's in standard format, elimination is always the easier method. Okay. So it's almost in standard format. In other words, we've got the first one in standard format. The second one just needs to reverse the x and the y. So it's minus x plus 2y. Where standard format is where you have ax plus by equals c. Now, this elimination is relatively simple. What's my first step? It's equation 1. Equation 2.
I would multiply the bottom equation by 3.
And you have to multiply everything, both sides, by 3. So the new equation 2 is going to be minus 3x plus 6y equals minus 57. And I'm going to cross that one out. Okay? Just so we don't get confused. Because a lot of times when you're doing these simultaneous equations, you end up with equations all over the page, and it's easy to make a mistake. Now what are we going to do between equations 1 and the new equation 2?
So the 3's would cancel out.
Okay, what I'm going to do is add those two equations. That's an important concept to know that you can do. In other words, whenever you have two equations, no matter what they are, you can always add them. If I have a plus b equals c and x plus y equals c, I can add those. A plus b plus x plus y equals c plus z. So when I add these two, what do I get?
10y equals negative 80.
Okay. Gives us a y equal to what?
Negative 8.
Okay. Now, normally, in a math class, you'd have to go back in and figure out what x is.
Yeah.
Right? And you'd use the simplest equation, which is probably equation 2, the one I drew a line through, to figure out what x is. But notice the answers, we don't need to figure out. They only gave one y of minus 8. So this has to be the correct answer, and it would be wasted time and effort to go in and actually prove that x has to be 3. Okay? So that's one of the key things in taking the SAT test, is to make sure you don't, once you know the answer, don't check it. I mean, if you have extra time, fine, do it. But in general, time is such a key factor here that you don't want to waste time checking the answer.
Right.
All right, let's go ahead. 10. Just a word on that previous problem when you said I have no idea what to do. When I have a math problem and I don't have any idea where to begin, I find something I can do and do it. In other words, what I did have was an equation. A over B equals 2. So that's the only, I don't know if that was the correct starting spot or not, but it was something I could do. So I started solving for A. And a lot of times you'll find that that actually leads you to the correct answer. All right, number 10. What does it mean when they say, what does G of 4 mean?
When?
What are we going to do? There's our function. What does G of 4 mean?
When x is 4.
Okay. In other words, what you do is you take whatever's in the parentheses and substitute it for x. So G of 4, let's do that. What do we get? Up here. Substitute it.
So when you have like ax squared, do you square the x first?
Yes. In fact, the square does not apply to the a. There's a difference. If I have ax squared, that is not the same as this. The second one, I'm going to square the A also. But in the first one, there are no parentheses. And the only thing that exponent applies to is what is directly below it. Okay? So G of 4, let's plug it in. What's this term?
So squaring 4, 16.
16 what?
A.
I can write the A after or before.
Okay.
But it's A plus 24. Okay? So that's what G of 4 is. And they are telling us that's equal to A. So, now let's erase this part here. Don't need that anymore. Can you solve that equation for A?
-1.
Okay, so -1. So what our function really is, G of x equals -1 times x squared plus 24. Now, they want to know what G of -4 is. In other words, they're testing a lot of different principles on each of these questions. But the principle is the same. Whatever is in the parentheses, you plug it in for F. So tell me what to write on the right side of this. And I want you to do it step by step. I don't want you to do anything in your head. Just do a direct substitution.
Okay, so negative in parentheses, -4 squared.
Good. That's where the possibility of a mistake comes from. Those first lines. Now simplify. Always take care of your exponents first. What's -4 squared?
16.
Okay, so what is here?
-16.
Plus 20. Answer A.
Okay.
Now, there was a definite shortcut here. We went through a lot of work to solve this. Even if I wasn't instructing, it would have taken me 30 seconds, 45 seconds, whatever, maybe a full minute to do this problem. There is a shortcut realizing that whether I substitute 4 or -4 doesn't matter. I'm going to square it. Right? So G of 4 has to be the same as G of -4. I can make, merely by seeing that the function is squared, not cubed or taken to the 1 power, but squared, then G of 4 has to be equal to G of -4. I could say that with any number. G of 3 has to be equal to G of -3. Because this comes out the same regardless of whether you plug in a positive or a negative number for x. So it really was not necessary to calculate A. But that's the purpose of the medium or harder problem, is that there's the normal, tedious, slow way of doing it. And then there's a shortcut way where you spot it.
Okay.
It isn't always easy to spot, but all right, 11. Okay. Now, before we go to 11, let's just take a look at number 9 again. Was there another way to do that? Let's say you got to number 9, and I have no idea how to do it. I forget all about how to solve the system of equations. So what's another way to do the problem?
Like,
Back solve. If you cannot figure out how to do a problem, always see whether you can back solve. And what I mean by that is, does this satisfy the equation? In other words, you don't have to know how to solve simultaneous equations. You just need to check and see if that point works.
oh, okay.
Well, if I try that point in the equation that has the smallest numbers, what do I get? I get 2 times y minus 4 minus a minus 5 is plus 5. Is that equal to minus 19? No. I can immediately rule that one out. And then when I come across that one, that will work. I will produce the equation. And then I'll try it on that one, and it'll work, and I'm done. In other words, back solving works quite nicely. And I didn't have to know how to solve equations. All right, back to number 5. So just always keep that in mind when you come across a problem you don't know how to solve. Back solving is an option.
Okay.
Okay, here we also have 2 equations that are in y equals b plus mx format. Notice, in other words, that y equals x plus b. Just they've got it. Doesn't matter. Same thing. Now, it's important to recognize what the problem is here. B and C are to represent the price per pound in dollars, beef, or chicken. And that price is based on time. How many weeks after July 1st during the summer? So if it's the first week after July 1st, X is 1. Price of chicken, figure out what it is. Price of beef, figure out what it is. Okay, so look at what they asked. What was the price per pound of beef when it was equal to the price of a pound of chicken? So what can I do?
Do you like equal them to each other?
Yeah. In other words, this is going to be the price per chicken or beef. That's the price per chicken. I'm going to let B equal C. So I come down here. This is, and I'm going to let it equal. Now it becomes simple algebra problem. Go ahead and solve. Now, let me offer a suggestion.
Okay.
When you have an algebra problem that's got x's on both sides and numbers on both sides, the first decision you have to make is which side am I going to put the x's on in my final answer? The right side or the left side? How would you answer that for this one?
Is there like even a right answer for that, or do I just
There is, and I was just about to explain it. You want to put the x's on the side that give it a positive coefficient because it eliminates negative numbers. Notice that if I move this to the right side by subtracting it from both sides, I end up with 0.15x. And then if I move this number to the left side, I end up with 0.6. Both of those coefficients are positive numbers. Had I done it the reverse, If I'd have moved 0.4x over here, I would have had minus 0.15x. And then I would have had a number going that way, minus 60. And now I got to divide numbers by numbers. As long as I've been tutoring, I have never met a student that didn't do better with positive numbers than negative numbers.
Mm-hmm.
So if you have a choice, now sometimes it won't matter. Sometimes I can make this a positive coefficient, but I'll end up with a negative number on the other side. That's fine. But in general, I suggest you use that rule. It doesn't matter if the variable ends up being on the right side or the left side. So you are correct in that sense, that there is no right or wrong. But I do believe that if you keep your coefficients positive, you'll make less mistakes.
Okay.
Now, so if we solve this, we get x equals 4. But not an answer here. So what do we have to do? What was the price per pound when it was equal? Oh. What was the price per pound of beef? So they want to know what B is equal to when X is. What's 0.25 times 4?
1.
So what's the price?
$3.35.
There you go. Okay. Number 12. And the moment I see XY plane, I am going to start drawing my axis. There's Y, there's X. Okay, I'm going to draw that line. Passes through the origin. And it has a slope of 1/7. Is that a flat slope or a steep slope?
Flat.
You don't hear that echo? It's a full 1 second delay.
Oh.
Okay.
I didn't hear it.
I don't want to. The next fix would be I would have to log off of go to meeting and relog back on a different meeting number. So when I say is that first of all, do you have any problem with positive slopes or negative slopes?
No.
Okay. So you know what a positive 1/7. So is that a flat line or is it a deep line?
That'll be like a flatter slope.
Yeah, it's something like.
Yeah.
That's not even flat. That's about a 3. That's about a 1/3 slope there. But it doesn't matter. Which of the following lies on that line? You just back solve every single point. You might be able to. Does that one lie?
No.
No, that point's up here. How about the second one? 1,7.
Yeah, because isn't that like the first?
Well, now hold on. Here would be 1. 7 would be way up there.
Oh, okay. Yeah.
So no, that doesn't lie on there either. 7 comma 7. If I go all the way to 7 here, am I going to get up to 7 on the top?
No.
No, I don't think so. That one, no. Are we done with the problem?
there's only one answer left.
We are done with the problem. In other words, we spend no more mental energy on this, trying to determine whether that is on the line or not. What we have proven is that A is not, B is not, and C is not. Now, there is definitely a more mathematical way of doing this. If I was trying to write the equation of that line, what would it be? If this is my general format for an equation of a straight line, well, what is it here?
So like 1/7 would be M.
What's B?
0.
Okay. So that's our equation. Now the problem becomes much simpler because we can plug into this equation. Clearly, when x is 0, y is 0. That's not right. And if we were attempting to prove that, is this a true statement? Whoops, excuse me. Is this a true statement when y is 2 is x 14? Yes. That is true. So if it was not multiple choice, this is the way I would do it. Well, it has to be multiple choice since they're asking about a series of points. This is the mathematical way to do it, but graphically we were able to do it with just as much certainty, right? In other words, it was very clear that neither of those 3 points could be on that line that we drew.
Okay.
Now we're definitely in the harder part of the question. At least now we are. These are going to be the most difficult. So it's worth no. It's going to be true. So basically they're giving us this fraction and they want to know which answer is that fraction after we solve it. Can you use back solving on that?
Yeah.
No.
Not
really. In other words, in order to tell whether A is the correct answer, I got to solve it. I don't have any other way of telling. Now, there is one other technique. First of all, does this algebra give you problems?
A little bit. I didn't really learn like inequalities too much. So
believe it or not, that's not the problem. We can cross that out.
Okay.
The question really is, do you know how to add those fractions in the bottom?
Yeah.
Okay. Good. So we're going to work just with the denominator. I got to find a common denominator. And I'm going to add those 2 fractions. What's the common denominator going to be? In other words, the only way to add fractions is if they have a common denominator. Right now, these are 2 different denominators. So to find the common denominator when you're dealing with variables, one way to always do it is just to multiply. In other words, this has to be a common denominator. I'm not going to guarantee that it's the least common denominator, but it has to be a common denominator. Okay? Now we got to figure out the numerators. 1 was the numerator. So what do I have to have in this numerator so that that fraction does not change?
Yeah, I am kind of confused on this one.
About x plus 3. Now, can you see where that is the same as this?
Oh, okay, yeah.
Yeah, because the x plus 3 is canceled, leaving you with 1 over x plus 2. So using that same logic, what has to go in the upper right numerator?
The numerator on the second one?
X plus 2.
Yeah.
Yeah. Okay. So now we've got two fractions that have the same denominator. How do we handle that? What's the next step? We're adding them together. Here's our common denominator. That doesn't change when you're doing addition. So what you do is you add the numerators. What do you get when you add the numerators?
2x plus 5.
Okay. Remember this was the denominator. So I got another big fraction bar with a 1 over.
Right.
Now, how do I divide a fraction by a fraction?
You multiply them?
You flip and multiply. All you gotta do.
Oh, yeah, okay.
You can't multiply because that would be changing the problem. But if I flip and multiply, this is going to be my answer. X plus 2 times x plus 3, all divided by 2x plus 5. That's the answer. Now, which of those is that answer? Which one do you think?
B.
Yeah, it's pretty obvious. Without even doing this boiling. If we look at there's an x plus 5x plus 6, there's an x squared plus 5x plus 6, there's 1. Clearly, those two things multiplied together must be x squared plus 5x plus 6. So it's just a question of finding out which one's in the numerator and denominator problem.
Right. Okay.
Alright, now, having done all that math, I'm going to show you another way to do this. And this might be the most valuable tip I can give you. Because this particular technique, like back solving, can take some really hard problems and turn them into easy problems. Or easier problems. When you see a variable in the stem and every answer has that variable in it, that means you can pick whatever you want. And solve the problem. And the lowest numbers are always better because it makes the math easy. Okay? Now, normally I tell people, well, x has to be greater than 3. So at a minimum, we have to pick 4. Okay? So let's see what happens if we let x 4. Well, we got 1 over 6 plus 1 over 7. Now, we can solve that. That is 1 over, our common denominator is going to be 42. This is going to be 7 42s, and 6 42s is 13 42s. I flip that, becomes 42 over 13. That is the value of that expression when x equals 4. You with me?
Yep.
So, now, all I got to do is go through each of these expressions and find out which one is equal to 42 over 13 when I substitute 4 for x. Clearly not that one. That's equal to 9. but that is what I call picking numbers, where you do not have to know, you kind of have to know, because you have to be able to solve that. In other words, you still have to be able to solve a complex fraction, where you have, a fraction with the denominator being another fraction, or the numerator being another fraction. You want to be able to handle those. But once you can, then you can use this technique and not have to solve that algebraically using the x's. It's a little bit easier, maybe not a lot, but the best way to solve 13 is by knowing how to do it algebraically.
Okay.
But if you didn't and you had time, then the next best way would be to solve it by picking numbers.
Okay.
Take a look at 4. Whoops. There's no 14. 14 must be below 13. There it is. So 14 and 15 are the last questions of this section. So they're going to be the hardest 2 questions of this section. And then the next section they go to, whether it's grid or calculator, starts all over again in order of difficulty. In other words, if we go down and look at the next section, it's the grid section, not multiple choice. Well, the first couple questions on that grid are going to be easy. It's back to easy, hard, and so forth. Okay?
Okay.
All right. So here they give us a linear equation. Just has an x and a y in it. Remember that the graph is a and they want to know the value of this exponential equation. First of all, let's take a look at the exponential equation. A lot of times you don't know which one to start with. But in this case, I'm always going to start with the exponential. Can I reduce this? Can I simplify this expression?
You can simplify 8 over 2. I just am confused on what you would do with the
Yeah, you can't really simplify the 8 over 2. In other words, if I have 8 to the 3rd power divided by 2 to the 7th power, that is not 4 to any power at all. So when exponents are involved, you can't do anything with the numbers unless the 2 numbers are the same. And that's the secret to this problem, is writing 8 as 2 cubed. Now, can you do that problem? Can you simplify the numerator? What's 2 to the 3rd to the x power equal?
8 to the x
No,
power?
you multiply the exponent. You definitely want to know your rules of exponents. Let's go over it. Tell me what this is. Now, excuse me, I made a horrible mistake there. Only when multiplying, not when adding. If I multiply 2 to the 3rd times 2 to the 4th, what's it equal to? 2 to the what?
7th.
Okay. When I take 2 to the 4th and divide it by 2 to the 3rd, what's that equal to? 2 to the what?
First.
Okay. And if I take 2 to the 3rd and I exponentiate that whole thing to the 4th, what does that equal to? 2 to the 12th. Okay, those are the 3 rules of exponents. Definitely learn. Those are the things we highlight in making sure everybody knows those rules of exponents. So, what is 2 to the 3rd to the x?
2 to the 3x power?
Now, the same base. So what is this equal to? Subtract the x.
So 3x minus y?
Bingo. What's the first part of this problem tell us?
Oh, okay. Yeah,
So what's the answer?
Would it be A?
Yeah. In other words, this is the same, since they told us that 3x minus y is 12, and this is 2 to the 12, which is A.
Okay.
Okay? And this problem will present itself in various ways. But this little trick where you go 8 is the power of 2 is the most common one. Let me give you one more example, because you're going to see problems like this. How do I solve that problem? Think the same kind of thinking we were just doing on that last problem. What is the common exponential base between 9 and 27?
Yeah, these ones are hard for me. So do you
Well,
look at like
the key question was, what is the common exponential base? It's not, we're not looking for a factor. 9 would be a factor of both 9 and 27. But 9 is not an exponential base of 27. What number is 3?
Okay.
In other words, I can write 9 as 3 squared
Okay.
to the x power, and I can write 27 as 3 cubed to the x minus 2 power. Now simplify that. What's that equal?
3 2x.
3 to 2x power. What's this one equal?
3 to the 3x minus 6th power.
Okay. Now, what can I do? One number to a different exponent equals the same number to a different exponent. So what can I do with those exponents?
Do you find the difference between them?
No, you make them equal to one another. In other words, the only way that can be a true statement is if 2x is equal to 3x minus 6. And that solves real easily. X equals 6. So I've proven that 9 to the 6th power equals 27 to the 4th power. But the way I did it was by finding this common exponential base. And I'm betting you at least 2 problems on the test to deal with this, where you have to find a common exponential base. What is the common exponential base between 8 and 4?
2.
Correct. What's the common exponential base between 25 and 125?
5.
You got it. You understand it. Okay. We've only got a few minutes, and this undoubtedly is going to be a hard problem. Hold on, let me look at it. Maybe it's not as hard as I thought. No, it is hard. I remember it before now. Why don't we start on 15 next time?
Okay.
Does that work for you?
Yep.
Okay. Abigail, I will talk to you next time, and I'll make a note that we stopped on 14.
Okay, awesome. Thank you so much.
You're welcome. Bye-bye.
Bye.